Hey there everybody, welcome back as we continue to talk about these markup and discount problems. So our I can statement today is the same. I can compute markup and discount problems. So let's start off with our warm-up here. It says if an item is on sale for 25% off, what percent of the original price is left? Okay, so we started off with 100% of the original price because that's just the whole thing, you know. The whole deal is 100% off. I mean, not 100% off. The whole deal is just 100%. So if the original price was $34, then 100% of the original price is the $34. So you always start off with 100%. And if you're taking off, like on a sale, you're going to be subtracting some, right? So if we're taking off 25% of that, you would subtract that 25% from the 100%, and you'd be left with 75% of that original price. So when an item is on sale for 25% off, you are left with 75% of that original price. And that can be really useful for us. Let's go ahead and look at example number 2. First, let's read. There's a quicker way to find the final price after a markup or a discount. It has to do with the warm-up question. Okay, we're going to use this in our example number 2. Now, this is kind of a different way to solve the same exact kind of problems that you were solving on the previous assignment yesterday. And if you'd rather continue solving those the same way, that's completely fine. But I'm here to offer you a different way to do it if you would like to use that. So here in example 2a, it says a new pair of shoes that normally sells for $45. So this is the original price right here. It was discounted by 35%. So for that discount, that means the price is going down, right? 35%. What is the new price? Okay, so what we would usually do, well, what we were doing before is this. We were taking that original price, we are multiplying it by the percentage. Let's make sure we move our decimal point over 2 places, and we're going to get it like that. And then this is going to tell us the amount of the discount. So 45, let's see here. 45 times 0.35 equals $15.75. So now to figure out the new price, I have to subtract the discount from the original. So that would be 45 minus the $15.75. And what is that going to give me? 45 minus 15.75 gives me $29.25. Okay, and so that would be my new price. So this up here is the discount, and this down here is the new price. But what if we use this kind of thinking to solve the same problem? Well, instead of doing it this way, we're going to start off by subtracting 35 from 100. Now, if it was a markup, we'd add that 35 to 100. But this is a discount, so we're going to subtract it. So 100% minus 35%, that I can do in my head. That's going to equal 65%. Now, if you'd rather grab a calculator for that math, you go right ahead. That's totally fine. Now we got to just turn that into a decimal, so 0.65, and we're going to multiply that decimal by that original price, which is 45. So 45 times 0.65 equals, and let's figure out what that is. It should give us the same thing, and it does, $29.25. $29.25. So you can see that both ways get you the same new price. It's just a question of, do you want to subtract the percentages before you multiply? Or do you want to subtract the amount of discount after you multiply? It's just a question of when you do what. A lot of times this way is easier because the percentages are more likely to be a round number, especially in real life. You go to the store and it's 10% off or it's 25% off. So those are pretty easy numbers to work with. But again, it's all up to you. I'm giving you these options for you, and if you don't want to use them, that's totally fine. Also, if you want to do it, like say you're not sure about a problem, and you want to work it both ways and just make sure you get the same answer for both, that is an option for you as well. All right, so when you're thinking about this, let's go back to the end of the notes yesterday. If you don't have it in front of you, don't worry about it. I can show you mine. But remember, we left this question blank. It says, could we write a rule that would find the new price from the old price? Think about this and we'll talk about it in the next part. Well, that's now. So the new price is always a, guess what? Percentage. Yep. Everything's a percentage in this unit, right? It's always a percentage of the old price. So by saying this, we're just saying you can find the new price by taking the old price and multiplying it by some percentage. Okay, so let's keep going. It says, please note the final price is 100% plus the markup, or if it's a discount, minus the discount, of the old price or the original price. Either way, old or original price. Okay. Just like before, you will always end up adding or subtracting at some point, like we were just talking about, right? It's just a question of whether you want to add or subtract at the beginning or at the end of the problem. And then we're talking about all these kind of equations. I don't know about you, but I start looking at these and it just kind of makes my brain want to check out. So I wrote it for you guys a different way. If you want to think about it this way, awesome. But this is how I wrote it out for you. And if you want to like pause your video and write this down on the back of your page or at the bottom or something, you sure can. Let me just read it to you. These are your two methods. Both will get you the same answer. Method 1 is what we were using yesterday on 8.3a. Okay? So with a method 1, what you computed first was the old price times the percent change. The old price times the percent change gives you the dollar amount of either the discount or the markup. That's what this is. And then you either added it to or subtracted it from the old price. And that gave you the new price. So this is what you did yesterday. I'm going to read it now in the order I wrote it. The old price plus or minus, depending on whether it's a markup or a discount. This calculation, which is the old price times the percent change, equals the new price. Okay, the new method, if you would like to try it out, is taking that same old price and multiplying it by something that you calculate. You're going to have to take 100%. Always start with that. If it's a markup, you're going to add the percent change. So like if it says there's a 15% markup, you're going to do 100% plus 15%. But if it was 100% discount, you would do 100% minus a 15%. Okay? So you're going to do the old price times this new percentage that you calculate, and that will give you the new price. So you pick and choose. We're going to do a few problems with method 2 right now, just so you can see how it works. Keep in mind that method 2 is a good choice for the first half of your homework, but not for the second half of your homework. I'll go over that more later, but I just wanted to go ahead and say that right now. So just be a little careful as you get to, let me double check. I'm pretty sure it's the second page of your homework. Yeah, numbers 13 and onwards, you want to make sure you're using the same old method 1 like we were using before. Okay, so let's look at some examples. We're looking at example 3A. Okay, so you've got some $200 concert tickets and a 145% markup. That is a big markup on some tickets that were already not cheap. Okay, let's figure this out. So let's do it the old way first. I know I said we would do it the new way, but we're going to do this one both ways. Okay, so let's take our $200 concert tickets and let's figure out the price of the increase. So we're going to multiply this times, we have to change this into a decimal, right? So grab that decimal point that you know is living right there, move it 2 spaces, and it's going to be 1.45. So 200 times 1.45. And that's going to equal the amount of the markup. All right, calculators out, and we got 200 times 1.45. So it looks like we're going to add another $290 to the price of the tickets. Okay, so this is the amount of the markup. That's not even the total price. We have to take this and add it back to the original price. So 200 plus 290, we can do that in our heads. That's going to be $490. Is there anyone that you would pay $490 to go see? I'm not so sure. I'd have to think about that one for a while. Okay, now what if we did it the other way? All right, so remember the other way is to take the old price. Okay, that's $200. And we're going to multiply it. So I just wrote my parentheses to indicate multiplication. We're going to multiply it by 100% plus the markup. So 100% plus 145%, that's going to be 245%. And 245%, move that decimal 2 places, you get 2.45. All right, let me throw this in the calculator and see what we get. 200 times 2.45, and you get 490, which is exactly what we got in our last step on the other problem. So 490. So here you have method 1, here you have method 2. You guys choose. Do the way that you want to do that makes the most sense to you, okay? All right, let's look at part B. So if you're someone who likes method 1, I'm going to assume you're already a pro at that. We're going to not do method 1 anymore. We're just going to skip to method 2. That doesn't mean you have to use method 2. I just want to showcase it a little bit more. All right, so using method 2, we've got the old price here, $12.95 for the book. Now what do we have here? A 22% discount. So we're going to multiply that 12.95 times 100% minus the 22%. And that's going to give us the new price. Okay, I did that kind of half in math language and half in English. So let's see if I can get this all into math language. So we're going to do 12.95 times. Now let's go ahead and subtract these. I can do that in my head. That's going to be 78%. And instead of writing the percent sign, I'm just going to go ahead and move my decimal over 2 places. It's going to be 0.78. So let's multiply that. Okay, 12.95 times 0.78. It looks like we're going to be $10.10. That one there isn't enough to bump it up, so we're just going to be $10.10. And that's going to be the new price right there. Okay, let's do another one. So you've got a necklace for $24.95. And it looks like it's got an 18% discount. So again, I'm going to kind of do it the same way I set it up here. I'm going to do 100% minus 18%, and that's going to equal the new price for me. Okay, so now let me get everything converted to an equation. So $24.95. I'm going to subtract this. That's going to get me 82%. I'm going to write down the 82. Before I write that percent sign, I'm going to go ahead and just skip the percent sign and put it in a decimal instead. So 82%, move that 2 places, it becomes 0.82. And then what does that equal? That's what we need to figure out. Let's grab calculators. We got 24.95 times 0.82. And you're going to get $20.45, except we've got a 9 there, so that's going to bump it up to a 6. So $20.46. 20.46. Okay. So, and then if you want to kind of double check, you want to look at your original price, and you know you got a discount, so your final price should be lower than the original. Okay. Was it a huge discount? Nah, 18%. I mean, it's less than half. It's even less than a quarter. So did our price go way down? No, it went down, but it didn't go like way down. It wasn't like $2 or something crazy. So this is a reasonable answer. Let's go ahead to part D. So let's see, $56.74 for your meal. Whoops, try that again, 56.74. This time you have a 15% markup. Okay, so instead of subtracting my percentages, I'm going to add them, which is probably even a little easier. So you're going to add those percentages, multiply it out, and that's going to give you the new price. So let's do that. 56.74 times 100 plus 15 is 115%. Now make it into a decimal. Take that decimal point that you know is there and move it 2 places over. It's going to wind up right there. And grab your calculator. You've got 56.75 times 1.15. And that is going to give you $65.26. There's some other decimals here, but 2 isn't a big enough number to make that bump up to a 7. So we'll leave it as a 6. $65.26. And that is your new price. And just to look and make sure it makes sense, first of all, it's a markup. So is our new price bigger than our old price? Yes, it is. Good. Was it a crazy huge markup? No, it was just a little one, so it should be a few dollars higher. And it is. It looks like it's less than $10 higher. So it's a reasonable answer. Great. Okay. So these were all kind of using our new trick, our method 2. This last problem is going to be kind of like the later problems on your assignment tonight, problems 13 and on. You are not going to use the new trick on this one. So let's read this. A shirt you won at the store was $27.95. But when you go to buy it, it's only $23.45. Hey, that's good news, right? What is the percent discount? Okay, so first of all, this is kind of like when we were filling out the table in the assignment from yesterday, which was 8.3a. So we need to figure out the amount of the discount. So we've got the old price, we've got the new price. What we don't have is the percentage discount or the amount of the discount. And the question it's asking for is the percent of the discount. So in order to find that percent discount, we need to figure out the dollar amount of the discount. How can you find out how much is discounted? You're going to subtract these numbers, right? So let's do $27.95 minus the new price of $23.45. Okay, so when you subtract those, let's see, $27.95 minus 23.45, you're going to get 4.5, which if you put another zero there, it's just $4.50. So it looks like the discount was $4.50. I'm going to just write that down so that I don't get lost in the middle of my problem and think, well, what was that number all about? You know, it's helpful to remember these things. Okay, so you know that $27.95 times some percent discount gives you $4.50. And if you want to write it as words, you could say the discount equals, or the discount is, P percent of $27.95, which is, of course, the original price. Okay, now we know what the discount is, and that's $4.50. So $4.50 is P percent of $27.95. So let's write that in math. That's going to be $4.50 times P equals, nope, I just did that wrong. Did you guys catch that? Awesome work if you caught it. Remember the is your equal sign. So $4.50 is, so that's my equal sign, some kind of percentage of, which is multiplication, so P times $27.95. So your equation might look like this. Or maybe you wrote it the other way around. Maybe you wrote $27.95 times the percentage equals $4.50. That is completely right too. Both of these are the same thing, just different order. So let's go ahead and divide both sides by $27.95 to get the P by itself. And my calculator will help me do that. So 4.5, or you could put the 0 if you want, it doesn't matter, divided by 27.95 equals this, 0.16100. So let's see, I'm going to write it over here because this one actually has room. P equals 0.16100. That's enough room where I can move the decimal point and still have a couple decimal places and round to my nearest hundredth. I didn't mean to cross that out. There we go. Okay, so now I need to express this as a percentage, not as a decimal. So I've got to move that decimal point 2 places to the right. And it's going to wind up right there. So I'm going to have 16.10%. Now, if you'd rather write 16.1%, totally correct. Both of these are fine. And let's just go back and make sure our answer makes sense, okay? So the shirt was $27.95, and then you start to buy it, and it goes down a few dollars. It's not like anything crazy. So the percent discount should be somewhere less than 50%, which it is. We have a pretty reasonable percentage. If you got like a tiny percentage, like point something percent, that would be suspicious because that's a really small percentage. It would only be a few pennies on this. So yeah, just making sure those numbers make sense. Let's take a very quick look at your assignment, and I'm not going to work the problems because these are the same as what we were just doing. You can use method 1 or method 2 on these. Now when you get to the other page, these are just like the first page, but when you get to 13 and on, remember to do them kind of the old school way with method 1. All right, and if you need any help, if you have any questions, just let me know. I'm here for you. Bye.